This is page 47, problem number 6, where we have an object pushed up a ramp at a constant velocity that has friction with some applied force, and we're trying to find the applied force. So the first thing to do is the free body diagram. Force of gravity down, normal force perpendicular to the ramp, an applied force this way, and a frictional force kinetic down. We will also call up the ramp the positive x and perpendicular to the ramp the positive y. If we go on from there, we can say, well, the net force in the y direction is equal to 0, which is equal to Fn minus Fgy. The net force in the x direction equals 0, which is equal to Fa minus Fk minus Fgx. We still need to find the components of Fg, so we say Fgx is equal to mg sine theta, and Fgy is equal to mg cosine theta. That means that we have the additional information that the normal force is equal to mg cosine theta. And that means once we have the normal force as mg cosine theta, we can say, oh, well, then the force of kinetic friction, which is mu k times the normal force, is just mu k times mg cosine theta. We can now write out the applied force is equal to Fk plus Fgx. So the applied force must be equal to mu k mg cosine theta plus Fgx, which is mg sine theta. All of these are constants or known values. So that's going to be 0.8 times 10 kilograms times 10 meters per second squared times the cosine of 30 degrees plus 10 kilograms times 10 meters per second squared times the sine of 30 degrees. So the applied force should then be equal to, I'll do a quick calculation, giving you an applied force of 119 newtons.